My name is Corey Hunter, and I'll be giving a presentation on conducting a correlational analysis. First, we're going to go over the agenda. We're going to start our discussions looking at the data. Then after reviewing the data, we're going to state our hypothesis. We're going to go over how we import the data into PSPP. We're going to conduct the correlational test using PSPP. Then we're going to review the output of PSPP and present our findings. We're going to then discuss the main takeaways, and then we go into any questions. So first, let's look at the data that we're going to be analyzing. The data was generated from a survey where we asked participants questions about income, debt, savings, etc. So from the survey, this information was self-reported by the participants. And the currency, this was a survey done in the Midwest of the United States. And from the data, we've identified a few variables, the variables that we're interested in finding the correlation. So for example, we have income, debt, savings, stocks, wallet, which represents the amount of cash an individual carries in their wallet, number of cars, number of credit cards, number of defaults a participant incurred. And we also did the data also had a Likert scale where participants were able to give information of their comfort level based on their current financial standing, with 0 being very uncomfortable and 4 very comfortable. Correlational test. We have to have the variables. We are comparing one variable against another. So if we're going to be looking at these 10 variables against each other, we just developed a little a chart showing each variable against the other. So the question we're asking is there a correlation between income, let's say, and debt? And if so, what is the nature of this relationship? And by nature of the relationship, we're referring to how do the two variables correlate? Is there a strong positive correlation, or a moderate negative correlation, or is there no correlation at all? Now, to start our analysis, we need to state our hypothesis. So first, based on the APA format, this is the format we'll use to state our null hypothesis and our alternative hypothesis, and give information on how we interpret the data. So for example, we'll be comparing income and debt. So the hypothesis test, the first statement says the first continuous variable, income, and the second continuous variable, debt. The null hypothesis states there is no correlation between income and debt, or R is 0. The alternate hypothesis states there is a correlation between income and debt, and where R is not equal to 0. So in order for us to reject the null, we're looking for a p-value less than alpha, where alpha is 0.05. Now that we have stated our hypothesis, we're going to start our analysis. So we're going to import our data into PSPP, which is pretty simple. First, we open up PSPP and we select File, Import Data, select the file. In this case, we selected a spreadsheet in a CSV format, and then we hit next. It will ask a few questions just to be able to prepare the data for analysis. So in this case, we had to select the second line as the first line of data, and by checking the box, we're indicating that the line above the selected line contains the variable names. Then you hit next, and once the data looks appropriate, then we hit apply. Once we hit apply, then the data is successfully imported into PSPP, and it should look similar to this. We just made a quick review to make sure that there are no blank cells. Once we have the data imported, the next step is to conduct the actual test using PSPP, which is pretty simple. We're now going to analyze the data, so we're going to check analyze. We're going to use a bivariate correlation, and then we're going to choose the two variables that we're going to test. So in this case, we chose income and debt. Our test of significance will be a two-tailed test, and we're going to tell the software to flag significant correlations, and then we hit OK. Once you hit OK, you get an output showing your correlation matrix. And this is what the output looks like from PSPP. As you can see in the first case where we did income and debt, we're showing a R, which is the correlation coefficient R as negative 0.05 and a p-value of 5.35. And in the second case, income and savings, R is 0.91 and a p-value of 0.000, and so on. Now once we've got all the output, we've got all the analysis done, we're then going to present our findings in that APA format we mentioned earlier. And what we did, from the 10 pairs of correlation tests we did, we found significant correlations with 6, which are the ones we're going to discuss in this presentation. So the first is the test of the correlation relationship between income and savings. Following correlation test was conducted. Null hypothesis states there is no correlation between income and savings. The alternate hypothesis states there is a correlation between income and savings. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha is 0.05. A significant correlation emerged where R equals 0.91 and our p-value is 0.000, which is really close to 0. So the test rejected the null hypothesis and concluded there was a correlation between income and savings. So the same was observed with income and stocks, where again our null hypothesis will always state that there is no correlation between the one variable versus the next, in this case income and stocks, and the alternative will be there is a correlation between income and stocks. And from this we can tell the R value is 0.19 and our p-value is 0.018, which again is less than 0.05, less than our alpha, which allows us, or which we can now reject the null hypothesis based on our p-value being less than alpha. And we can conclude that there was a correlation between income and stocks. income and wallet. We did our analysis, and PSPP gave us a R value of 1 and a p-value of 0.000. And again, with a p-value of 0.000, here we're stating that we can reject the null hypothesis, and with a R value of 1, that's a strong positive correlation. So we can conclude that we can reject our null hypothesis and conclude that there was a correlation between income and wallet. Also here, between savings and stocks, we can tell that there is a correlation. The correlation coefficient of 0.28 is not as strong as 1, but our p-value is very, very close to 0, so we can definitely reject the null hypothesis and conclude that there was a correlation between savings and stocks. And also with savings and wallet, again, R value very close to 1, so a very high correlation value, and a p-value of very, very close to 0. So in this case, the test rejected the null hypothesis and concluded there was a correlation between savings and wallet. Also, with stocks and wallet, our R value is 0.19 and a p-value of 0.017 is less than 0.05, which allows us to reject the null hypothesis and conclude that there was a correlation between stocks and the amount of cash someone carries in their wallet. So now that we've done our analysis, some key takeaways. The use of statistical software such as PSPP can be very helpful when conducting correlation tests. It's quick and the information is generated quickly, and also our APA format for presenting the results gives us a standard for showing the results and giving our conclusions. Also, assuming that alpha is 0.05, we will reject the null hypothesis when the p-value is less than alpha and fail to reject the null hypothesis when p is greater than alpha. The correlation coefficient is represented by R, and its value ranges from -1, which indicates a negative correlation, to +1, which represents a positive correlation. And with the PSPP, with software, we're able to quickly represent the data as scatter plots, which can also help us justify our conclusion. Well, that's it. Thank you for watching. And if you have any questions or comments, just please feel free to drop them below. Thanks.